Now, just to reiterate, in Chapter 5, we're still working on this top level here for evaluating atmospheric stability. This is how important this is to our environment, to our daily weather, and to our climate overall. So we're going to spend a little bit more time now looking into conditional instability, which is aligned with the average environmental lapse rate that circulates the air around our atmosphere and around our globe, so that we do have an average temperature of about 57 degrees Fahrenheit from equator to poles. And it is due to this updraft and downdraft and global circulation, which we are promoting here with our study of atmospheric stability. So we're still on the top rung here. Let's go into conditional instability, which is what you're seeing here for what we call fair weather cumulus clouds. And much of the time, our atmosphere averages in this area, in this wedge on a sounding. So we observe these clouds. When we look at the data, we'll see lapse rates in this wedge. The average is at about 6.5 degrees Celsius per 1,000 meters. That has a moderate slope to it. When we do the calculations for these slopes, we can see anywhere from about a 3-degree drop per 1,000 meters to about an 8-degree drop per 1,000 meters on the other side. So we've moved from stable environments, which were noted for their inversions or for their isothermal lapse rates, to now conditionally unstable environments, which are known for lapse rates that go from about 3 degrees Celsius per 1,000 to about 8 degrees Celsius per 1,000. The average is around 6.5. In doing this, we observe updrafts and downdrafts, which we will get to, along with the expansional cooling and the compressional warming that you're noting here. It's a healthy atmosphere that can move air and circulate air. When we look at the data and calculate it, we start to see in here above the isothermal area, we get back to a conditionally unstable slope, much like the slope for the forced lift below it. And this is one that I calculated here, drops about 5 degrees Celsius per 1,000 meters between about 1,500 meters here and about, going up to about 2,600 meters here. We've lost from initial at about 23 degrees Celsius minus our final or our later at about 18 degrees Celsius. That difference is about 5 degrees Celsius per 1,000 meters, well within the range between 3 and 8 for conditionally unstable. So here's our nice area here, which mimics our force lifting for conditionally unstable. Now remember, we said that the average over time or over the entire atmosphere would be conditionally unstable. We are figuring in this inversion, this isothermal, these conditionally unstable, and now we're going to get beyond here in a bit and look at what is beyond. But before we do that, let's look at some variations of conditionally unstable. You see that these clouds look a little bit different from these clouds, which look a little bit different from the clouds down here at the downdraft. And those clouds can all be due to the range of lapses that you see in this area. So let's look into the range of those lapses. For instance, if you have force lift in each of these different areas, you can still see different types of clouds based on the conditionally unstable lapse rates that you see above the force lift. For instance, here you've got a short area, a short altitude change before you get into an isothermal stable environment. So you've got a short window for lifting that parcel up, condensing it, and forming a cloud. That might be what you see here for these shorter clouds. They may note that they've got a shorter altitude for their conditionally unstable environment before they start to hit an isothermal or even an inversion area above it. When you look at clouds that are have a little bit more vertical development, those are cumulus congestus clouds, beautiful clouds, often seen later in the day. They have a little bit more of the conditionally unstable lapse rate because this cloud is in an environment that is a bit warmer, and so it can rise above that warmth and maintain a little bit more altitude in that conditionally unstable environment. When you're talking cumulonimbus, which is back here and more toward the unstable environments, that means that you've had a long run of conditionally unstable, bordering on unstable environments here.